And our next speaker will be Hamza Bilgin from Robot Bosch company, who will talk about enabling unique product traceability using artificial intelligence. So, the stage is yours.
Thank you. Hello, everyone. I will try to give you some information about production a bit, and also how we use the AI in this area. We are part of a startup named Physically Unclonable Tracking under Bosch, and simply we do untraceable things traceable in production, or you can call in-plant tracking or tracking of parts in production. So, what is that? So, let's say in a conventional world, how do we make traceability? We should start from that point. Normally, there are some products in production, and there are some process data, like temperature, heat, I don't know, RPM of the machine, etc. And all of them are affecting the quality of the part. However, in order to connect it to the product, we need to know which product are we processing in that specific machine or test station or the quality control station. So in a normal world, we are just using data metrics codes or serial numbers on the product, etc. But those are very good technologies. However, you cannot apply it to every kind of parts. Sometimes it is very difficult, could be costly, could be just because of you need to put a huge station on the production and it is like impossible. So what we are doing is using specifically an AI algorithm and very generic camera, and we are taking one photo of the part whenever the process steps is like next step is. So one photo is here and one photo in the second place that we want to trace the part. So from the first photo, we distinguish a lot of details of the surface, like your fingerprint. Like all of you have some unique fingerprints, right? So exactly like this, we are taking a lot of details of the surface, and whenever we take another photo of the same part in production, we can simply say, this is the part, let's say 1, 2, 3, 4, and printing nothing on the surface. And the infrastructure or technology is applied very simply. So we have just one camera, which is, let's say, 6 megapixel of camera, and industrial PC behind. And on top of it, we just have the algorithm. So we take the camera image, let's say 15 megabytes, and we get a lot of features from the surface, let's say 10 kilobyte of data, and we erase the image. With that 10 kilobyte of data, we can know or recognize the part wherever it is. And simply, we don't touch the hardware part. Hardware part can be made by the manufacturers, right? We just do the software part. And did we apply it? Of course, we applied in the beginning to Bosch. This is a part produced in Bosch, China. It is a very simple injector component. However, it is very complicated for traceability. It is very difficult to put a QR code there, or data metrics code, or serial number. So we are taking photos of it in a batch of 150,000, and we can distinguish every single component in that batch, just with one photo. So those are the photos. I think this is the beauty of AI. Even though you change the positioning in the first two photos you can see, or like the lighting condition, or with different subcomponents, without components, or with scratches on the surface, we can still distinguish the part. And is it like only applicable to that kind of surface? No. We tried a lot of components and different materials like leather, forged metal, casted metal, or any kind of metals, even metal sheets, or even glass. As long as there is a good photo of a part that you want to trace, our algorithm can just make it happen. Simply, we have applied it Bosch, and this is one of the applications. I can also, explain some other scenarios, but more or less, I would like to just explain you this in this moment. And if you have any question, you can just approach us. We are on booth 10D25. So please welcome. And we can just show you more details on the topic, more or less. This is my presentation, and you can connect me via LinkedIn.
Thank you very much.
I hope I saved also some time.
You saved a lot of time. For me as a host, this is brilliant because now we can end up in time, so perfect. And the room's up for a lot of questions if you want. So don't hesitate to ask some questions.
There's one?
There's one, yep.
So the tech looked quite good to me, like it's really interesting one. So what do you explain that you take a picture, and then you erase that picture and you extract some features.
Yes.
And then you send that feature over some network. So you do some compression over there, or is it like a lossless compression or something?
No, it's like, I mean, we can of course do it, but it is like 10 kilobytes per photo. Even if theoretically you have 10 millions of product, it is still manageable data size. And we have some central server, of course. We just put all the data there, and we just use it whenever it is necessary. So.
And then when you have a lot of similar products, do you have like a serial number, like you can extract serial number with these features, or like how you can manage the same thing with these just 10 KBs of extracted features?
It can be thousands of, if I understand correctly, if there is like 100,000 of product from the same production line with the same surface, doesn't matter, we can distinguish all of them with the unique serial number. Of course, the serial number will not be printed on the product, but whenever you show the product to a camera, the algorithm will just say you the serial number.
Okay, thank you, thank you.
Any more questions?
Are there further questions? Then, if this doesn't seem the case, then thank you very much. Well explained.
Thank you very much.